Hey, good morning. Welcome back. We're going to be doing something a little difficult today. I've actually spent the last week trying to find a solution to this problem without going through the guide itself. So as you know, you can go through these algorithm challenges. There is an answer key you can look up for them on the official guide itself. But I try to go through, find my own solution, which tends to be a little more clunky, and then maybe go back and try to take a look at and optimize my code and figure out what I could have done better. And that's just a good way to learn. And so that's why I try to walk you guys through as we go along the different things that we have to learn about. And plus, I'm kind of skewed towards showing you guys and building on certain skills to try to teach you as we go along versus just kind of going through the algorithms and projects. So I'm going to start off with sharing my screen, and I'm going to share with you what has taken me a week of my time to try to figure out. And I'm going to start off with my first failure here. And I wasn't far off. If you noticed, we had some arrays here where we were looking at. We have these factorials. We've done factorials in another challenge here. And I've got this for loop here that looks like something that's confusing to you probably. And I have a return where I'm trying to check to see what my outputs are and failing miserably. All right, that's good. I wanted to start off with a failure for you. So what are we doing? We are essentially taking permutations. So what are permutations? Well, let's just go through, and this is what they give us for permutations. Math is fun, yay. What's the difference? Well, here's what you can look at. You're looking at a combination in something like a combination lock, or you're looking at something like a permutation. So here's a permutation lock. I like the visualization of this. You have all of these numbers. There's 3 rows of these, and how many combinations of these numbers can we have? All right, so this is an ordered combination. However, we want something special with ours. We're adding another layer of this saying that I only want the combinations that don't have 2 letters back to back or 2 values back to back. So we're going to have to filter all of our results. So how are we going to go ahead and go about doing this? Well, we know that if we're going to be filtering our results, it sounds like regular expressions. Well, because it is regular expressions. And we're going to be testing our parameters using the regular expression.test prototype, all right, which is something we've used before. And remember, we just have a regular expression object, and you just write .test and the string that you want to test. All right, since we're going to be swapping around values to generate an array, just like here. So imagine that we're going to isolate each one of these digits. All right, in our case, we just have lowercase letters. So we're going to make these spots in an array. So these 0, 1, 2 spots in an array, and then we're just going to be jumbling all of these up. And then we're going to test them to see if, for example, instead of 813, we have something like 883 or AAB. And I want to filter and chuck that value out. So again, we can do that with a regular expression. And that means we're going to be taking a string. We're starting off with a string, mind you. So that means we're going to go from a string to an array. We're going to be using split for that again. And then when we test, we have to remember to join that back together. All right, so there's our permutations. Also, the regular expression that we're going to be using, here's our website here that we use. And you can see I already have a solution here. We're only really dealing with lowercase letters, but here is how we can select things. Remember that we start off with our capture groups here. And again, all I've did is go over to, from my thing here, right to my cheat sheet, all right? And you can see that we have our capture groups, all right? Remember, our capture groups is what we're going to be looking for. The next thing that we have is standard global search. So if we don't have that global search, it's going to stop at that first value that we find. We don't want that first value. For say, we want a global search to search all of this text. Now, for what we're doing, we're only going to be testing one string, so we actually don't need that global search because we're going to be inputting a string using a test method. So that's why we don't actually need this global for our project. The next thing that we have here is a back reference or a /1. All right, back reference to group number 1, which means find, essentially capture group number 1 is a dot. That means find anything. and then find anything again. So anything, and then match that same anything. So an S and an S, a 0 and a 0. All right. And then match one or more, which means find something, something. All right. And then if you find a third something, capture that as well. So that like 5, 5, you have 5, 5, 5, or 0, 0, 0, or A, or Z, 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 which is part of our challenge. So there's a simple regular expression. We don't really need to capture everything for what we're doing. We could actually say is we can capture the lower A to Z, because that's all we're really concerned about is lowercase letters in this challenge. But since it says no repeats, please, you can interpret that as you will. This is a very specific. And since our code really should be specific to our task, I'm actually going to be using this instead, mainly because, like I said, I want to keep everything, only capture exactly what we're being asked to capture in our test. That just helps later on as well. Much later on down the road, just so you know. So there's your regular expressions. Hopefully you're starting to get comfortable with regular expressions, because you can see how they're very useful for certain things, especially as long as we keep them short and we test them. This is a great website to test them, like I always do. I like this a lot. All right, it's time for a confession, boys and girls. Here is the official repository from freeCodeCamp with the explanation that I was talking about. And this is where I really had to go to. I started out trying to figure out what to do, coming through here, understanding our permutations. The way we want to do these permutations is you can kind of take a look at this. And we want to start off with our different positions. So we have an introduce A, and you can kind of see how we're going to be swapping letters out to move these values around. All right. So this is a pretty good visual method of seeing it. But again, this wasn't quite as clear. And again, here's another one that's not quite as clear. Essentially, what we want to do is go over to Heaps algorithm. All right, so they've followed this link to Heaps algorithm. That's essentially what we're really doing. So we have the permutations, which we went through, but now we're going to be using this Heaps algorithm to solve it. And here's a very short Wikipedia entry on Heaps algorithm. Basically, this guy, Heap, 1963, an algorithm that minimizes movement. It generates each permutation from the previous one by interchanging a single pair of elements. The other n-2 elements are not disturbed. Basically, this is very useful, and from what I've heard, even on interviews for jobs, this has been a question. So through my other research, like I said, I've been messing with this for about a week or so. And here's a visual observation about how we're going to be swapping each element. Now, how does this actually work, and how do we make sure we don't have any repeats of the, we just want unique values, and that's really what the Heaps algorithm is about. It doesn't take into account something like duplicates. We're only really concerned about swapping the values of this array, not what the values actually are, or if any of these values, A, B, C, or D, they can be anything. They could be 1, 2, 3, 4, 5. They could be a 1, a 4, and a 3, an A, an A, an A, and a B. And it doesn't really matter. It's just swapping those positions using an array. And here's how we do it. This is the basic pseudocode. However, this boils down very, very simply, all right? Basically, there's n number of elements, okay? What we're doing here is we're going to be using a recursive method. Notice that we are in a generate function here, where n is any integer and a is an array. So we need to get our string to an array, and we're going to have generate, and we're going to be calling generate on itself. All right. So as long as a, or n rather, so if n equals 1, and then we're just going to output our final. All right. Now, n is going to be an integer. Okay. Notice that when we call it generate on itself, okay, so we have to start generate off, kick that off with some integer. It's going to be larger than 1. So since it's not 1, else we're going to go into a for loop where we are going to generate n-1. So what's going to happen is we're going to be decrementing n each each iteration of this loop. All right. So remember, this is a recursive method, which means we're calling the function on itself. So how many times is this going to run? How do we know this isn't going to be an infinite loop? Well, we have this escape here that says if n equals 1. And guess what we're going to be using? So for example, we're going to take n to start off as going to be the length of our array. So if the length of our array is 6, we're going to start off with 6. We're going to call generate on that initial length. Okay, and then we're going to come in here, do our for loop, and what's going to start off with this is n minus 1. So what n minus 1 is going to do is it's going to decrement n. So if it was 6, it's going to go down to 5. And then we're going to be swapping values. All right, and then do it again. So then n now is going to be 4, then 3, then 2, then 1. Then once it's 1, guess what? We're just going to output everything. All right, that we get. But what are we outputting? Well, that's what this for loop is going to do. Okay, that's what this for loop is going to do. After we decrement our n minus 1, we're really going to be calling these swap functions. So we're going to need a helper function for swap. And what swap is going to do, we're going to generate these permutations. And the key of this is what positions are we going to swap? All right, and here we go. All right, let's see. This generates all permutations. If n is odd, right here, we switch the first element and add 1 to the counter I and repeat. All right. No, I switch a line here. If look at this, I'm going cross-eyed in my own thing here. I have to take my glasses off to read. If n is odd, we switch the element with the last one. If n is even, we switch it with the ith element. This is what this does. Okay, what does that mean? We have a counter here, I. So in our for loop, we have another counter, I. If it's even, all right, we're going to swap the ith element, okay, with and then replace that with that n minus 1. If it's odd, all right, let's see. If it's odd, what we're going to do is we're going to swap that 0th element with that n minus 1 element that we started with. Okay, so notice that this n minus 1 spot, all right, which is what we're calling this generate on, which is the current position that we are on rather. We either swap that with whatever we are iterating through the array with or the initial value. So we're going to be swapping, let's say B. All right, B is even, so I'm going to swap that with the starting value. All right, so it's even. So then let's take a look at the next one. All right, we have is going to be odd, right? So we're going to swap that then with the third value here, and so on and so forth. So that's basically what we're doing. You're going to kind of take a look at this. And like I said, I've been taking a look at this for like a week or so to try to wrap my mind around this whole process. And even if you don't really understand exactly what's going on, you can figure out that basically if it's even, you're going to be swapping out whatever position we are on in our for loop with either that value, or we're going to be swapping it with the first value, basing it on whether it's either even or odd. And remember, we can find an even or odd using the modulo or the remainder, okay, which is that percent sign again, all right? If we divide something by 2, all right, and the result and the remainder is 0, that means it's even. If we get a result that's not 0, then we know it's odd, right? If it's 1 or -1, we know that it's odd. All right, and either way, we're going to be swapping out with the element we are that n minus 1, and then the only thing that's going to change is whether the array sub I or the array 0. All right, now that we have all of that, how do we go through and code this? All right, so that's hopefully a little bit clearer than mud. So let's go down, and this is where, after all of my failures, I've came down and I've really took a look at all of this and just adapted this. All right. So here's their explanations, which I didn't really think were very clear either. So let's go ahead and start building this out. What do we need to do? First off, get rid of my horrible failures. You don't even have to. Don't even want you to see that. where I started off trying to go through and find the combinations here. And if you notice, we have the permutations repetition, where we're taking things to an exponent, and then we even get down into these factorials here with these examples, which don't exactly work out the same way, but this is what I was trying to go, is based on this math down here and then filtering it later, which I failed at, which there is a way to do it. I just did it wrong. So I went right ahead with the recursive method because it looks better. And honestly, if you're going to be using this solution for an actual project, you're going to find the most applicable solution. And then, so if this is a common solution to a problem using Heaps algorithm, you wouldn't make up your own, which is going to be longer and more clunky. You would just use it and make sure it functions properly, right? So that's what we're going to do. So the first thing I'm going to do is I just need an array to start off with, right? Because Heaps algorithm needs an array. So I need an array. And how do we get an array from a string? All right, we apply a string method split. And again, we've done this many, many times. All right, so and there's my array. I'm going to need another variable in here as well. And we can generate an array and then return the array.length after I filter it. Or, all right, I'm going to cheat, because I don't really care about what the permutations are. I'm just looking for a number. All right, look, I have a counter. So I'm just going to set my counter, and every time I iterate through my loop, I'm just going to add 1 to the counter. So every time I add a successful permutation to my output array, or I would add a successful permutation to my output array, which I'm not even going to do because I don't need to, because it just takes up more memory, I'm just going to add 1 to my counter instead. Much easier. The next thing that we really do need for Heaps algorithm, all right, is swap. Swap. So swap's got to be a separate function. So what does swap do? Swaps positions. Put A in B and put B in A. All right. So how do we do that? Well, we can't just assign A to B, then B to A, because if we do that, then they're both going to equal each other. So how do I do that? Well, you need to store one of the variables in variables in a temporary spot before you swap it with something else. So what I have to do is I'm going to call swap, because that's what the pseudocode calls swap, and I'm going to swap A and B. So I'm just swapping 2 numbers, all right? And these numbers are going to represent the index positions. So they're going to be, integers. And those integers are going to be the index positions of the array that I'm going to be generating, that I'm going to be swapping letters around, that then I could push to a separate array if I wanted to gather all of my permutations. But I'm not going to do that because I don't want to, again, waste any memory or anything like that. There's no reason to if all I want to do is count. So I'm just going to be counting instead. Once I swap them, oh yeah, that does work. All right, and then go ahead and let's just go ahead and add 1 to the counter. That's all. All right. So since Heaps algorithm takes care of all of that, now I just have to add in one other filter here. I'm not even going to go through and filter the array. I'm just going to add another regular expression test. So I need a variable. All right, temp. All right, and then in this temp, I'm going to store, now, right now, array. This is what's important to remember. This array is nothing but the input string split. All right. So if I want to, all I'll do is I'll do this for you here. I'll put that return. So you know, ARR A. Run this just to show you. So here's my array. So right now I just returned this ARR. All right. So you can see now I have an array of all of this stuff. So I'm going to swap this. So I'm going to store this in the temporary. Then I'm going to swap this. So I'm going to reassign this ARR A. Now A is going to be a number, whether it's going to be like, these are going to be numbers like 0 and 1, or 0 and 5, or 0 and 6. That goes back to Heaps algorithm. Over here, where we're going to be swapping, our swap's going to take in 2 values, all right, an A and a B, and swap them. If it's even, it's going to be wherever I am in this for loop. If it's odd, I'm just going to swap with the beginning of that array. So then I can take this, I'm going to reassign this to wherever this B is. And now I can just take this ARRB, which is the up position, and I can assign that to the temp. Okay. So I assigned A to B and B to the temp, which is where I temporarily stored A. So A is B, and then B is A. Now remember, if I had written this out where like, the reason we have to do this is because if A equals B, right, and then B equals A, all right, that's not swapping them. That's just assigning them to each other, and they're the same thing. So we don't want to assign them as the same thing, right? All right, so there's your swap function. And again, there's a helper function for swap. All right, here we go. We know at the end, the very end of our program here, all right, we know that we only need to return this counter variable, right? And we do need to, that's not what I want to generate. Right, I'm going to call generate, and this is going to be a function. Again, so generate. I'm going to call this function generate. All right, and this generate function is going to take in an integer, and that integer needs to be the length of the array. All right, so I'm going to go ahead, and so there's my function generate, which I didn't populate yet. All right, so there's my function generate. All right, and generate needs to take in an integer or a number. So I'm just going to say a number. So an integer is a number, and I'm going to do something, and I'm going to be using this swap method to swap around these pieces of the array. So don't forget that I also need to call and kick off this generate function, right? All right, which I haven't, not generate, I can't even type today, generate. And the integer that I want is the ARR dot length, or the length of the array, or in this case, 3, because I want to do 3 different, there's 3 different things I need to permutate here. All right, using Heaps algorithm. All right, and so this is what it would look like if it was an array of 4. This would be the procedure that I'm going through. There's that visual. All right. Let's end that sentence, okay? So this is going to be our flow. So I have a counter, I have an array, I have a swap method that I have to swap a bunch of stuff around using a specific algorithm, all right? And then I have this generate recursive function, all right? And this is just defined here. Then I need to actually kick off this generate function using whatever the length of this array is. And I'm just going to return a counter, which means instead of pushing the permutations to a separate array, I'm just going to use a counter. So all of this should be pretty clear. This is where we're going to get a little confusing. All right, so I'm going to start off with an if statement. So in the beginning here, if n equals 1, so this is going to be the end of our recursive function, okay? So I'm starting off with, this is the way to escape the function, and that's going to be if n equals 1. So if n so when n equals 1, although there's something else that we need to do, because we're going to be taking these permutations, all right? So n equals 1, which means we've gone through all of this stuff. And because we're going to have 2 counters, because remember, we're going to have this for loop in here too. All right, so when n equals 1, and we want to add something to the counter when n equals 1. That means we have a permutation, and then we're going to call that generate function again on itself. So each time this happens, we would then push the result, but I don't want to push the result here. I'm going to leave this and open for a second. All right, I am just going to take the right? So this is when n equals 1, which means I have permutated all the values that I wanted for that one cycle. And I want to have a check here. I don't want to add one to the counter unless I don't have, where are we at? I don't have these doubles or triples happening. So how do I say that? Well, I need my regular expression dot test. For example, here is the regular expression. Remember, it has 2 forward slashes dot test and then the string that we want to test. And what we can do is we can test for these. Remember, these are a positive, right? But I want this not to happen. So remember the not, I don't want that to happen. So not, remember we have 2 forward slashes. And inside our forward slashes, I need a capture group. And inside that capture group, I want to capture, just for our cases, the lowercase a to z. Right? And so that's one capture group. Okay. And then after that capture group, I need a \1, which back references that, which means that's going to give me an a to z, any value like an a, and then another a. But take a look at this. I just don't want to kick it off. Some of these might have multiple, like z, 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 z should return 0. So I just want any combination of those all together. Okay. So I have not. Here's my regular expression. All right. That's the end of my if statement. So right there, I need to test that, which means this is the regular expression I'm testing for, or testing that it's not. And since this happens as n equals 1 after I've gone through one cycle of these permutations, all right, I need to take this ARR and I have to join it together, all right? And what that's going to do is that's going to make sure that I have a string, all right? So that's going to be testing for the string. So after I've gone through and I've swapped everything and got my new permutation for my one cycle. Whew. That's right. That's all that is for. Now, and that's not even the hard one. This is going to be the more confusing one, actually. All right. So then this is going to be our else. This is our for loop, and right. And basically, here's our for loop, and then we call generate, and then if it's even or if it's odd. All right. And I'm just going right off of that. All right. So for, just like we've been doing before, ri equals 0. All right. As long as I is not equal to n, or less than n would also work. But again, in a Heaps algorithm, they say not equal to n, less than or equal to n minus 1. But that's going to be the n that's going to come in here. So not equal to n. I plus plus. Increment your I. So remember, we're incrementing the I and I'm decrementing the n, which is always fun. At least I'm pretty sure that's what we're doing here. And then we're going to be calling, this is our generate. All right. So here's our generate. And what are we generating? We're generating, right? Generate, so I'm taking an integer. We're only going to generate n minus 1, not n. All right. And then we're going to swap. All right. And then we have to make sure we're swapping positions. So here's a swap. And we could do this shorthand. Remember, if it's even, so n modulo 2 means the remainder of 2. If that equals 0, okay? If that equals 0, all right? If that statement there is true, all right, that means it's even. If it's even, what do? Let's go back over to here. If it's even, swap it with the ith element, okay? That ith element is going to be wherever we are in this for loop. So if it's true, swap with I. Let's see. Wait, is that right? Swap with I, okay. If modulo 2 is 0, we're going to swap with 0. No, if modulo 2 is there, modulo 2, yeah, if that's 0, we're going to swap with 0, right? Or if it's not, we're going to swap with I. Okay, there we go. All right, and then what are we going to swap that with? We're going to swap that with n minus 1. There we go. Whew. All right. Remember, this is the shorthand of an if-else statement. All right. So whether this is true or not. All right. So that's what this is. So n modulo 2. All right. True and false. If modulo 2. If it's 0, remember, 0 is a falsy value. So if it's false, that means it's odd. Therefore, we're going to swap with 0. If it's true, you'll get a 1. 1 is a truthy value. We'll get with the I. There we go. All right. Been staring at the same code for a while. That's what there we go. There's your explanation. Sorry about that. I kind of crossed that for a second. It'll happen. It'll happen to you. So now that we have all of that, I think we should be good. So all I did was go through, follow Heaps algorithm, double checked with this guide, which I've messed up 100 times, double checked my regular expressions, added in my test, make sure I understand what the permutations are, and feel that need for speed, finally. Now notice in here, in this counter, and when we add this counter, we could also push the results of this ARR. See how we joined this? So we can take this ARR.join and push this to a new permutations array and then actually have all the permutations. All right. And instead of returning the counter, I could return the length of that array. All right. So those are the two options if you actually want to see what the permutations are. But then again, some of these we're going to get really, really long. Like if you want to see what like these are here, you're going to have a really long, a really big array. So if you did the this thing right here, you're going to see the number here is going to be 3,600. All right. So you can kind of see there's 3,600 unique values in there. So you're going to have a very big array storing a lot of stuff. So that's why I just did the counter instead of pushing those values, which would go right here if you want to actually see this thing working. All right. So hopefully this was helpful. I tried to explain this pretty clearly without spending 3 hours in this, even though I know this has been a very long video already. So again, I will see you all next time. And again, hopefully it was helpful.